Good evening, ma'am.
Good evening. How are you all?
Good, ma'am. How are you?
I'm fine. Thank you. So I think I can start the session. It's 5:32. Today I am on time. So I think I have a privilege to start the
Good
session.
evening. Good
Good
evening.
morning. Yes, sir. So a very good evening to one and all. Today is day 4 and I think day 4. No, day 5 I think. Yes, it's day 5. Sorry. So today I'm going to talk about the independent sample test as per the brochure which is already shared with all of you. So according to that flyer you can find today is the day 5 and I'm going to discuss independent sample test. But I think I will include one more test, that is the paired sample test, that is the dependent sample test. Fine. So give me a second. I'm going to share my screen first. Just a minute. Yes. So I have shared my screen. I hope it is visible to everyone.
Yes, ma'am.
Yes, ma'am. It is visible.
Fine. So today as I said, I'm talking about independent sample test, right? So it is another parametric test. We have seen the definition of parametric test. So may I know how many of you are okay with the definition, and if anyone can state that or recall the definition which I have just quoted yesterday, it will be good, and then I'll proceed with the independent sample test. Anyone? Okay. No confirmations?
Good evening. Ma'am,
Good evening, ma'am.
parametric tests are tests that are used for to test population parameters. For example, you tested t-test, you used yesterday for the one sample test. So
Yes.
it was using mean as a population parameter for the various example. That is when parametric tests are used.
Very correct. Thank you, ma'am. May I know the name?
Ma'am, Ritika.
Ritika, ma'am. Very correct. So I think yesterday I tried to explain you that parametric tests are tests which are based on the parameters of the population, right? And apart from that, there are certain assumptions in case of parametric test. And one of the most important
Yes,
assumptions.
yes, ma'am. Yeah, ma'am. You told na that the basic difference between the parametric and non-parametric is, in simple word, if we say that in parametric test they have assumptions and non-parametric they
No,
don't
no.
have.
Uh, uh,
That's the
uh,
line of a. Is it so?
Wait a minute, ma'am. In both the cases, assumptions will
Yes.
be there. But in case of parametric test, the
Mm-hmm.
main assumption is of the normality, right? I think if you
Yes,
Yes.
can
ma'am. That's
recall
Yes.
the
right.
Yes.
day.
Normality is the right, ma'am.
Yes,
Basic,
yes.
right?
I think when you can recall the day 3 session where I discussed about the chi-square test, you can recall that thing that there is also one assumption, that is frequency count should not be less than 5 in 20, at least 20% of the set. Assumption was also
Mm-hmm.
there. So that means in all the statistical tests, there are certain assumptions. But when we talk about parametric tests, the main assumption is the normality assumption, right? So if
Oh,
as
right.
calculating normality, in that case, we are thinking of the some non-parametric tests.
Okay.
Fine.
Okay. Okay. Fine, ma'am.
Yeah. So starting with the agenda of the day, independent samples t-test. Generally, this test is known by with various different names like two samples t-test, independent samples t-test, or students t-test. These are the few synonyms of the independent samples t-test, or you can say this. You can call independent samples t-test by these names, right? So in books, you can generally find these names, right? Further, it is an inferential statistical test that determines whether there is a statistically significant difference between the means of two unrelated groups. So I think when I have read this sentence, you can you means you maybe you have observed this thing, or maybe you have see understand this thing, that I have given certain what I can say emphasis on few of the words. First one is, it is an inferential statistical test. Meaning is what? When I talk about inferential statistics, generally in case of inferential statistics, what we do, we generally use a sample, and using that sample we want to draw the characteristics of the sample for the population, or we can say we are drawing the conclusion on the basis of sample for the population. Those tests are known as the inferential, or those type of statistics known as the inferential statistics. And I think you all will agree with me when we talk about usually various type of statistical tests, especially the parametric test, if I say, or not only parametric, in some in many of cases it can be the non-parametric test also. We are generally collecting the data, right? We are generally collecting the we are taking the samples. Means we are having certain number of groups of people, and through that we are asking them certain questions, and we are collecting the data. So that means many a time it happens that when population size is very large, and it is not possible for us to reach each and every unit of the population. In that case, what we do, we are going for the sample extraction from the population. So, but we need to see this thing, that whether the sample is truly representing our population or not. So that way, in inferential statistics, we are trying to see this thing, that whether the sample is having the same characteristics which the population is having or not, right? So we want to draw the inference about the population using sample. This type of statistics is known as inferential statistics, and in this we can say independent sample independent sample t-test is one of the tests, right? So this test help us to determine statistical significant difference between the mean of the two unrelated groups. Unrelated groups meaning is what now? Means whatever two groups I will take, there should be no relationship in those two groups. So, for example, if I say I want to compare the opinion of the people on the basis of their marital status, for example, any particular brand, right? Maybe it is any perfume brand, or it can be any particular brand, right? So in that case, I'm saying marital status, so maybe I have divided my sample on the basis of these are the married people, these are the unmarried people, right? And then I'm collecting their responses. So these two groups are unrelated, because it is quite obvious a person who is married, he or she cannot be the part of the married group or unmarried group. Similarly, a person who is unmarried, he or she cannot be the part of the married group, right? So that way these two groups will be the unrelated groups, right? So the basic condition is you need to have the two groups, and those groups should be the unrelated to each other, and then you can find the significant mean difference in the particular variable whatever you are measuring, right? So this is the independent samples t-test. Then I think further in the next point you can read the meaning of unrelated groups. It is written, unrelated groups, also called unpaired groups or independent groups, and are groups in which the cases in each group are different. So I think you can now make sense from this particular line. When I say this thing, that particular person can be the part of only one group, he or she cannot be the part of the second group. In that way you can satisfy this particular condition of the independent samples t-test. Till here I am clear to everyone. May I proceed?
Yes, ma'am.
Yes, ma'am.
Ji, ma'am.
Yeah, thank you, ma'am. So here I tried to make you understand this thing using one example. Suppose I am having one particular variable, that is gender. So it is quite obvious. Generally, we can divide gender into the two parts, male and female. So male and female will be the two unrelated groups here, right? That a particular person, if he is a male, I cannot keep him in the female group, or if particular person is female, I cannot keep her in the male group, right? So that way I can say this thing, this is an example of unrelated groups. Further, talking about the requirement of the variables for independent samples t-test. I think before talking on this, if you can recall the day 1 session, there I told you this thing, we need to have the clarity about the variables, that how many variables we are having. Then we need to have the clarity about the type of the variables, means what is the measurement you have used to measure those variables. If you are having such clarity, then you can, according to the requirement of test, you can understand this thing, that which test you need to apply. And apart from that, you need to have one more understanding, that what is the purpose of your study, means whether you want to find the difference, relationship, or impact, or something like that, right? So that is the important thing. So when I talk about t-tests, generally t-test is we are using for finding the mean difference, right? Whether it is a one sample, or whether it is independent samples, or whether it is a paired samples, right? In all the cases, we are interested in finding the mean difference, right? So now, type of variables which is required for the independent samples t-test is, number one, we need to have independent variable. Sorry, we need to have dependent variables, right? Means both we are requiring. So firstly, I think I'm showing you the dependent variable. So we need to have one dependent variable, and its scale should be continuous. Means your variable should be continuous variable, right? Second, you need to have the independent variable. And here the case is, in case of independent variable, this variable should be categorical in nature. And apart from that, whatever categorical variable you are taking in that variable, there should be two labels, right? Or two groups, or two what I can say, samples, right? As I have shown you previously, gender. So we know this thing, like gender is a categorical variable. And suppose I am not considering the third gender, so I can say I am considering only two categories, that is male and female. So I am having a categorical variable with the two labels. So labels, categories, groups, and samples will be same here, right? Meaning is same. Either you are saying labels, or samples, or categories, or groups. Almost they are having the similar meaning here. Further, suppose I'm having a gender. I have already shown you this can be your independent variable, because gender is categorical in nature, and you can only categorize your data. You cannot make any comparison in these categories, right? So you cannot fix the order. That is why it is a categorical variable and of nominal type. Second, you can have the second example, occupation. In the occupation, suppose I am having the two categories, business class people and service class people. So again, I cannot compare whether the business class is earning more or service class is earning more. I cannot say this thing, or business class is superior or service class is superior. I cannot comment like this. So that way I can say I am classifying or dividing my population on the basis of their occupation. And suppose it is business class people and service class people. So that way only categorization is possible, and I cannot compare. I cannot say there is any magnitude is existing between those that is allowing me to compare these two, right? So this way, these are the two examples I tried to quote here for the independent variable. Fine, may I proceed?
Yes, ma'am.
Yes.
Yes, ma'am.
Now, yes, thank you for the confirmation. Next is the sample size. I think yesterday itself I had a word regarding the sample size. I have said this thing. Usually in statistical books, we are finding this thing when the sample size is greater than 30, we are going for the Z test. And when the sample size is less than or equals to 30, we are going for the T test. I think we all have studied this thing till now. If I talk about in the statistical books or in the research methodology books. But there is some more things which you need to see while applying the test. The thing is that you need to know the population standard deviation. If you are knowing the population standard deviation, you will go for the Z test. But if you are not having any idea about the standard deviation of the population, it is suggested to go for the T test. In that case, we are not considering the sample size. If you are having sample size greater than 30 also, in that case also you will go for the T test. And when I talk about SPSS, I think those who have applied the various statistical tests using SPSS, they are knowing this thing. Generally, there is T test available in the case of SPSS. Reason being, as it is quite obvious, whatever population we are talking about, maybe it will be large, and maybe we do not have the idea about the standard deviation of population, right? So in that case also, we are applying the T test, right? And I think there is one more term. If you have heard about central limit theorem in statistics. So generally, when after introduction of the central limit theorem, this is a notion that if the sample size is greater than 30, right? So generally your data is trying to move for the normality. Generally there is a means when the sample size is small, generally data is not meeting with the requirement of the normal distribution. But when you're increasing the sample size, so your data is tending towards to the normality. So that is why your t test is almost similar to your z test. This is the basic concept. Is it clear?
Yes, ma'am.
Yes, yes, thank you. Further, I think these are the formulation ways of the hypothesis. Here you can find the first is the mu1 is equals to mu2. That means it is saying that the two sample from whatever population they have drawn, they are having the same mean. Mu is for the population mean. If you can recall, yesterday also I have told this thing. Mu is the representation of the population mean. So I am considering this thing that from whatever two groups I'm having and from whatever population they have been drawn by us, they are having the same population mean. That is mu1 is equals to mu2. Alternatively, you are saying that these two are not equal. And if you can recall, I said this thing when you are saying alternatively that both the means are not equal. So the meaning of this is that there are two tails involved, because I'm not clearly specifying whether mu1 is greater than or mu2 is greater than. I'm only stating this thing that mu1 is not equals to mu2. Next is, if you are stating your null hypothesis as mu1 is greater than and equals to mu2, and alternatively you're saying this thing alternatively and clearly you are stating here that mu1 is less than mu2. That means you're clearly saying that one of the mean is less than to the other mean. That way it is a one-tail test. And third condition is also similar, only you are saying this thing that mu1 is less than or equals to mu2, and here you are saying mu1 is greater than mu2. So it is a clear indication that way it is a case of one-tailed test. So if you're talking about two-tailed test, in that case, your rejection reason falls on both the tails, because both the tails are involved here, and this is the remaining reason where you are accepting your null hypothesis. Similarly, when you're talking about the one-tailed test, right? In that case, on either of the tail, your rejection reason will fall and the remaining reason will become your acceptance reason. Like this also you can see this time it is falling on the right tail. So according to, if it is falling on the right tail, that means this is a right tail test, right? And in the previous you can see this is the left tail test because it is falling on the left tail. This rejection reason is falling on the left tail, right? So this way, this is the what I can say symbolical representation of your hypothesis. You can write this hypothesis in the form of word also, right? Like there is no significant difference in the group 1 mean and group 2 mean, right? So this is this one. This is where you are saying this thing that there is no significant difference, means both are equal, right? So this is the first representation in the word form. Second, you are saying that group 1 mean is significantly less than or equal to your group mean. Then you are saying group 1 mean is significantly more than or equal to group 2 mean. So these two are the cases of one-tailed test, right? Now, talking about generally means this is again one more representation. If you are saying mu1 is equals to mu2 and mu1 is not equals to mu2, you can write these two in this way also, that mu1 is not equals to mu2, sorry, mu1 minus mu2 is equals to 0, means you are transferring mu2 from right side to the left side. So you can see the sign has changed from plus to it is becoming minus. So that way it is mu1 minus mu2 is equals to 0. And same with this, so it is not equals to 0, right? Till now I'm clear to everyone. May I proceed?
Yes, ma'am. Proceed.
Yeah, thank you. Now this is the procedure which I have shown in case of one sample t-test also. That means here you need to define your null and alternative hypothesis. Firstly, you will set your alpha value, that is the level of significance. You will calculate the degrees of freedom. In case of generally independent samples t-test, degree of freedom manually can be calculated using this particular formula. That is sample size of the first group minus 1, sample size of the second group minus 1. Then you need to state the decision rule that suppose if your calculated value is less than tabulated value, you are going to accept the null hypothesis. and vice versa. So this rule is according to the manual calculation. But other way around, if I talk about for the p-value rule that I have already told you, that if your p-value is less than your level of significance, you are going to reject the null hypothesis, right? So that way you need to see whether you are performing manually or using any software. So this is a case of manual calculation, right? Then you will calculate the value of t. Generally, this is the formula. Using that, you can calculate the value of t. Even the softwares are using the same kind of formula, right? So x1 bar, x2 bar is clear to everyone. These are the means of both the groups. SP is the pooled standard deviation, or SP square if I say. This is the pooled variance. N1 and N2 are the sample sizes of the both the groups, right? Then how to calculate SP? This is the formula. So that way you can go for this. But when your SP means, I'll need to show you this thing right previously. So here you can find if your standard deviation or variance is same for both the groups, right? In that case, this will be the formula for the pooled mean. But if it is not similar, means for both the samples your variance is not same, in that case this is the second way of getting the t value and calculating the degrees of freedom, right? Further, talking about, you can use the table if you are performing manual calculations, and using table you can get the tabulated value, and you can compare your calculated and tabulated values. So here you can see I tried to make you explain this thing. Suppose you have calculated the value of t using the formula and you are getting its value as 1.78, right? And you have assumed that your alpha is 5%, and suppose your sample size is coming as suppose your degrees of freedom is coming as 12, right? So now how you can find the t value using the table? So for that, I have told you yesterday, you need to have the knowledge of the degrees of freedom, and you need to have the knowledge of your level of significance. Using these two figures, you can get the t value. So it is clearly mentioned. Suppose our degrees of freedom is 12. So 12 we can locate in this column, which is this one, and level of significance is 5%, which is this. So in the intersection of these two means 2.179 will be your t table value, or t, this is known as the critical value of t, right? Now you can compare your calculated and tabulated values. So 1.78 is less than your 2.179, right? So you're writing here that your t calculated is less than your t tabulated. And if you can recall the thumb rule, if this is the case, we are going to accept our null hypothesis. So this is I have shown you for the manual calculation purpose. Now talking about the assumptions of independent samples t-test. So there are 6 assumptions which you can find on a slide. The first one says the independent variable should be categorical. That is, it should be a nominal or the ordinal scale variable. If this variable has 3 or more categories, we must decide before running the test which categories we want to compare. So for the independent sample t-test, we need to have one independent variable that will be the categorical variable. And here we need to know this thing. So means it is quite possible that in your categorical variable there are more than 2 categories. In that case, you need to priorly decide in which 2 categories you want to make comparison, because the t-test independent samples t-test limitation is that it can compare only 2 groups or 2 categories, right? So this is the first. Second is dependent variable should be continuous. This is, I think I already told you. The third is there is independence of observations. I think this is already we discussed, that if we are taking 2 unrelated groups, that way also we can achieve this particular assumption. And second way is we need to collect data from one person only once. Only that way we can make sure that we have made this particular assumption, right? So that means first 3 assumptions, if you will look on the slide, are what? They are generally are from the researchers side only, means, and these are the observational things you need to observe by your own, that on which scale you have measured which variable. And then you can, if you see that one categorical variable is available with you and one continuous variable is available with you, and you have maintained this thing that you are collecting data from one person only once, and a particular person is a part of only one group, he or she is not part of second group. Means it is like, I can say this thing. One more thing is possible here. Usually, what we do means, this is, I am talking in terms of my students. What generally I have observed, what they do. Same student. Suppose there is a student who is male, and my student is requesting him, please fill my questionnaire, and then that particular student, means my student's friend, suppose that friend is becoming female also, means he or she is filling the second questionnaire as a female also. It is quite possible. Usually people can do such kind of things. So if this is the case, that means your third assumption is violated, right? Fourth one is the dependent variable should be normally distributed in both the groups. So if suppose I'm having two groups of my categorical variable, so what is my dependent variable is, I need to see in both the groups, it should be normally distributed. So that I think we will see there in the SPSS. Next is the dependent variable has no significant outliers in either of the group. So whatever two groups I am having, in both the groups, the dependent variable should have no outliers, right? Lastly, the variances of the dependent variable in two groups are equal. So you need to see whatever is the two groups you are having. In those two groups, the variance of the dependent variable should be same, right? So that way, these are the 6 assumptions. First 3 we can maintain by our own. Remaining 3 we can assess or evaluate using the software, right? So talking about if any of the assumption is violated, so you can perform the non-parametric test, which is named as Mann-Whitney-U test. I think this graph I already showed you yesterday. This is for the understanding whether your variable is normally distributed or not. So this is the depiction of the normality that is we are using or denoting or depicting by the histogram. Further talking about the Levens test, here you can find in the Levens test, we can say null hypothesis. I think yesterday I told you, no, I think yesterday we have not seen Levens test. So for homogeneity of variances, that is the last assumption of the t test, independent samples t test, you need to use Levens test, right? In this Levens test, the hypothesis is sigma 1 square minus sigma 2 square equals to 0, or sigma 1 square is equals to sigma 2 square, right? That means I am saying this thing, that the population variances of two groups, that is group 1 and group 2, are equal, right? Then this way you can I'll tell you this thing, that how you can calculate or find this particular assumption in the SPSS. Further, how to perform independent samples t-test in SPSS. So this is the process. Then I think we are all set now to go to the SPSS and performing the independent samples t-test. So I hope it is fine. May I proceed with the independent samples t-test now?
जी madam.
Yes. So give me a second. I'm going to share my screen for the independent. I think I forgot to open a sheet. Just a minute. Give me a second. I think I shared with all of you data with the name employee data, right?
No
Any
shared.
concern?
No shared. No shared.
No, I think on WhatsApp I shared data.
Oh, WhatsApp. जी madam.
Yes. Fine. It is fine. My screen is visible.
Yes ma'am.
Yeah. Here you can see we are having so many different variables available in this data set, which is employee data. Again, I will tell you, this is the data which is already collected and used. So please do not use this data for your study, right? Do not take any of the data or variable data from this data set, because it is already used. So it is not ethical to take such perform or take any such kind of actions, right? So this is my humble request from all of you. Moving ahead, you can see we are having ID, gender, birth date, then education, job category, salary, etc. So we are having so many variables. Suppose I am taking the variable gender. Second variable I am taking as the salary. So suppose I am taking these two variables, gender and salary, and I want to perform, suppose, independent sample status. So can any one of you tell me which variable here is the continuous variable?
Ma'am, salary, ma'am. Salary, ma'am.
Very correct.
Salary.
Very correct. Thank you, everyone. Very correct. Salary is a continuous variable or numeric variable, and gender is
Discrete
Categorical
variable.
variable.
sorry, discrete, and second one is
Ma'am, categorical variable.
it's a categorical variable. Very correct. Very true. It's a categorical variable, and we can say this thing. How many categories there?
Male,
Two, ma'am.
two,
Male and female.
two,
Two.
two,
Very
two,
correct. Two categories are there, right? So that means first thing we have seen, we have one continuous scale variable or numeric variable, and second we have the categorical variable with the two categories. So two assumptions we have checked, right? Third assumption, suppose I am telling you this, that I collected this data using one single I can say that one single person was the part of only particular group only, right? So that way we can say we have what I can say, we have achieved the first three assumptions of the independent sample status. Now further three, that is normality, outliers, and the homogeneity of the variances, right? What you need to do? Right. So now what you need to do? You need to go to the analyze, go to the descriptive statistics, and select explore. I hope now people will be habitual of doing this, right? So I hope you got it.
Yes, ma'am.
Yeah. So click on the explore. Once you are clicking on the explore, you will be on this particular window or box. There you can find all the variables of the sheet is listed at the left hand side. You need to shift them in the right hand side boxes according to your need. So I'm expecting you to select the current salary and shift it to the dependent list box. Done? Shifting done?
Yes, yes, yes.
Yes, ma'am.
Now select the gender and shift it to the factor list box. Done?
Yes, ma'am.
Now click on the statistics. By default, descriptives is selected. So click on continue. Click on the plots. Select here the histogram. Deselect stem and leaf and select normality plots with tests. Done.
Then, madam, continue.
Fine. Click on the continue. Click on the OK. I hope my output window is visible. Visible?
Yes,
Yes.
ma'am.
Yes. So now we will see that how to read the table. So first table is of the case processing summary. This table says we are having total of means out of just a minute. So here you can find that we are having total 216 females, right? We are having total 258 males, right? Now for these two different groups or categories, you can go further and you can check there is no missing value, and this is the total observations, right? This is the table number 1. Table number 2 is for the descriptive statistics. This table you can see for the current salary, we are getting all the statistics for male and female individually. You can find this, right? If I talk about female, I can say that the mean salary for the female is 26,031.92, right? For the male, it is 41,441.78. 95% confidence interval for mean is, for the female is 25,018.29, 27,045.55 for the female, and for the males it is 39,000 something and 43,000 something. 5% trimmed mean is 25,248. Here it is 39,445. Likewise, you can see the median, variance, standard deviation, minimum of the salary for the male, female, and the range, interquartile range, skewness and kurtosis. Most important thing is you can compare your mean and median. There is a difference when I talk about the mean and median for the female salary. Similarly, coming to the male, you can compare the mean salary and the median salary, and you can find there is a large difference in the mean and median salary for the male, right? Coming to the skewness and the kurtosis part, if I look at the kurtosis, skewness part for the males, for the female salary, you can see it is 1.863, which is in the range, if you can recall, which I have told you to consider, which is -2 to +2, right? So it is in the range, but kurtosis is violating the range. It is exceeding the range. It is 4.641. And can anyone tell me what was the range of the kurtosis?
Ma'am, +3 to -3, -3 to +3.
-2 to +3. Very correct. Very good, ma'am. Then, on the basis of skewness and kurtosis, I think there is little dilemma, and probably we can say that salary is not normally distributed because mean and median is also having a large difference for the female. Coming to the male, mean and median are not very close. Talking about the skewness and kurtosis, so in the case of female, you can find that both the values, that is skewness and kurtosis, are according to the range, right? So it's in between -2 to +2, and it is in between -3 to +3. But still, if you are not understanding this thing, you can refer the next table, which is the test of normality. Here we can consider the Shapiro-Wilks test, right? So we can see the significant value for male and female current salary, which is 0.000. So it is less than 0.05, right? It is less than 0.05, right? That meaning is what? That means we are going to reject the null hypothesis of the Shapiro-Wilks test. And if anyone can tell me what is the hypothesis for Shapiro-Wilks? Yes?
Some variable is normally distributed.
Very correct. Variable is normally distributed, and this is the null hypothesis, which ma'am said, right? But our data is not supporting the null hypothesis. We are concluding this thing that variable is not normally distributed, right? So that means current salary for either male group or for female group, for both the groups, it is not normally distributed, right? Fine.
Yes, ma'am.
Yeah. Moving ahead, talking about the histogram. So I think you can see histogram is also saying the similar type of thing. It is indicating that salary is positively skewed. And when you can look at the values of the skewness, you can find both the values were positive also, right? And the diagram is also saying that your data is positively skewed for the female group, right? Similarly, for the male group also, your salary variable is positively skewed, right? Looking at the QQ plots, these are also stating the similar thing, right? The data points are not following the fitted line. These are violating, or these are very far away from the line. So that way you can say this thing that your variable salary is not normally distributed for the female group, and similarly for the male group also, right? Coming down, looking at the box plots, yes. So you can see this thing in both the cases. We can find we are having certain asterisk. Here we can find in case of male category, we are having a single asterisk sign. But here when I talk about the female category, here we can see there are so many asterisks which are overlapping each other. So that way there are significant outliers available in the data, right? So two assumptions we have checked. that is last two, I think I mean to say. The fourth and fifth we have checked. Now the last one, which is homogeneity or variance, is remaining, which you can see in the output of the independent sample status, right? So firstly, we need to see how to perform independent sample test. So for that, I'm suggesting you go to the analyze, go to the compare means, and select independent sample status. Fine. Everyone has found this independent sample status. May I click on this?
Yes, ma'am.
Yeah. Once you are clicking on this, similar kind of box we are getting here as well. Now what you need to do, you need to select your variable, which is the dependent variable. Which is the dependent variable here? Can anyone tell me? I think before performing this, can anyone tell me what will be our hypothesis according to the two variables which we have considered? Anyone?
There is no
Salary.
significant difference between male and female regarding salary.
Okay. Okay, fine. I
No
think we can.
significant difference between the salaries of male and female.
Yeah, very correct. So we can say this thing that there is no significant mean difference in the salary, or we can say there is no significant difference in the mean salary of male and female employees. Fine.
Yes, ma'am.
Yes.
Yes, ma'am.
Yeah. So if you want to write, you can write this thing. There is no significant difference in the mean salary of male and female employees. So that way, current salary is my dependent variable, which I'm shifting in the test variable box. Now I want to compare salary on the basis of gender. So I'm shifting this gender on the in the grouping variable box. Fine.
जी madam.
Now you can find when we are shifting the gender here, you can see there are two question marks. And after shifting this variable, there is one button which is define groups. It is activated. So that means it is requiring we need to define our groups here. So you need to click on this define. Right. So here, I think I need to check. I don't think so. I would be just a minute. I am canceling this. You do not need to do that. I want to see in the variable view the what is the labels we have. Yes, it is female and male, right? Close this. So again, I'm going analyze, compare means, selecting the independent samples, shifting the current salary in the test variable box, shifting the gender into the grouping variable box, and clicking on the define groups. So here I'm defining F group 1 and M is group 2. Fine.
जी ma'am.
If you have coded your data in form of number 1 and 2, so whatever is your means, you can define here group 1 is 1, group 2 is 2. So it is not mandatory. You can go in that way also. If you have given numbers to the male and female, that also you can allot here. Fine.
जी madam.
Now click on the continue. Apart from that, there is no need to do. You need to see here confidence level value is 95%. According to your need, you can make changes in this. But I will continue with this because I am okay with the 5% level of significance or 95% confidence interval. Click on the continue. Go to the OK. And in that output window, I hope you can get the output. Fine.
Yes, ma'am.
Now
Yes,
you
ma'am.
now you can see the first table is the group statistics table, where you can see you are having the current salary variable, and this variable is for the male and female group. And I think this is we have already seen that in the female group we can say there are 216 females, and in the male group there are 258 males. The mean salary for female is 26,000 something. For male, it is 41,000 something. These are the standard deviations, and next one is the standard error of mean. Next, the important table is of the independent sample status, where you can see, as I told you, the last assumption we can check in the output of the t-test, so that you can see here the first section where I'm hovering my mouse. You can see I'm rotating my mouse on this. This is the Levens test, right? So this Levens test for equality of variances, I think the hypothesis I have already shown you, that sigma 1 is square is equals to sigma 2 square. You can find here that the F value is 119.669 and the significant value is 0.000, right? So when you will compare this P value from your level of significance, which is 0.05, you can easily conclude this thing that this is less than 0.05. That means you are not going to accept your null hypothesis. That means null hypothesis is saying sigma 1 square is equal to sigma 2 square. That means variance is equal, right? So you are not accepting that null hypothesis. You are rejecting it. And alternatively, you are saying that variance is not equal. Is it clear to everyone?
Yes, ma'am.
Okay. So if variance is not equal, you can see in the first column, there are two things mentioned. Equal variance is assumed and equal variance is not assumed. So according to the Levens test, we are rejecting its hypothesis. So we are concluding equal variance not assumed, right? So that means we do not need to do anything with the first row now. It is of no use now. We will go in the second row and we will report the results of the second row. You can find here the t value is coming as minus 11.688 and the degrees of freedom is 344.262. Significant level is 0.000. Mean difference is this minus 15.409 and further. So main thing is you need to see further in the next lot. You need to compare. You need to see the significant value of the t, which is this 0.000. So this 000 is less than 0.05 in case of t test. So in case of this, we are rejecting the null hypothesis of the t test, and we are concluding this thing that there is a significant difference in the mean salary of the male and female employees. Is it clear?
Yes, ma'am.
Yes, ma'am.
Yeah. Now you can see further, if I see the mean difference, which is minus 15,409, right? So I can say this thing that who is drawing more salary or more mean salary, male or female? Yes. Who is drawing more mean salary?
Male.
Male. And you can recall once we have defined our group there, we have given first group as the female and second group as the male. And this value is coming as negative. So why it is negative? Because it is female mean salary minus male female salary. So if you want to use, you can use your calculator also. Using that, you can take the difference. This will be this difference only, right? So that way we can say this thing that females are drawing less and males are drawing more mean salary in comparison to the females. Is it clear?
Yes, ma'am.
Yes. So this way, this is the independent sample status. Only these things you need to report in your results when you want to, or when you are writing any research paper, right? Further, any questions till now, or may I proceed with the next agenda?
Proceed, ma'am.
Proceed. Thank you. So now I will just a minute talk about the next test, which is the paired sample status. Visible to everyone's light? Slide is visible? Yeah.
Yes.
Yes. So here I will talk about paired sample status. So when I am talking about paired samples, previously we were talking about independent sample status, where the situation was you need to have two unrelated groups, right? So here we need to have paired groups. So this is the difference. Means purpose of paired sample status is also find the difference, mean difference. But here in case of paired sample status, we will be having the paired groups, right? So how or what is the meaning of these paired groups is, it is very simple. Suppose I'm having the patients, right? And I have checked their BP and I have noted down their BP. So suppose I'm having 10 patients, so I have jotted down their BP values, right? And then I have given certain medicines to them. Suppose all the patients are having the high blood pressure. So then I have given the medicine. I have recommended a medicine to them, right? So after suppose 15 days, again I have measured their BP, right? And then I have noted down their BP values. So that way means for the same group of people, twice I have collected the data. So group is same, there is a pairing. Suppose 10 people I am having or 10 patients I am having, and in the second lot also I need to have 10 same patients, right? So that way there is a pairing possible. And I can say that if suppose before medicine, this was the BP of person number 1, and after the medicine, this is the BP of the person number 1. Likewise. So that way, this is a case of paired sample status. Generally, paired sample status type of things are used mostly in the medical fields, right? Where you are doing some experiment, there you can use paired sample status, I can say. So if you are doing experiment in teaching, like if you are teaching your student first time any particular concept, so you want to know what is their basic understanding, you can take a quiz of those students, then you can teach them, and then again after teaching you can collect the scores of these students on the same questions. That way you can compare their knowledge. Similarly, in a organization, suppose a particular manager, suppose he or she knows the performance level of the employees of the organization, and suppose he or she has sent them for a particular training, right? After taking the training, when the employees are coming back to the organization, they will perform, and again their performance can be is recorded, and then comparison can be made. So something like that, where you are doing some experiment, in that case you are using the paired samples t-test, right? So I hope related groups is clear here. May I proceed?
Yes, ma'am.
Yes. Now, there are certain assumptions of paired sample status. The first one says dependent variable is continuous and it is measured twice on the same sample of the subjects, right? So that means that I have told you, means same people, number of people you need to use, and you need to collect data to those people twice. After a certain period of time, you will collect such type of data, and that will become the continuous variable for you. The differences between the scores of variables are normally distributed. So that means whatever two scores you have collected, means whatever data you collected twice, you need to take the difference of that. And for the difference, you need to find the normality assumption. Lastly, the differences between the scores of the variables do not have any particular outliers. So you need to check whatever is the difference is coming, then you need to check whether the difference is having the outlier or not, right? So how hypothesis formulation for in the case of paired sample status will be the mean difference between the variable scores is equal to 0 in the total population, or you can make it like the mean difference between the variable scores is different from the 0 in the total population, right? I think this is the thumb rule I have written, which I already told you. Now, in case of paired sample status, what things you need to report? You need to report the test value, that is the t value. You need to report the degrees of freedom. You need to report the p value, mean difference, and the confidence interval of the difference. These are the 5 things you generally report. In case of even means it is not like in case of t. In case of independent sample status also, you need to only report these things. Let remaining can be some extra output which you are getting, which is necessary to calculate these things, right? So I hope it is fine. May I proceed? How to perform paired sample status? Yes.
Yes, ma'am.
Yeah. So I think I have shared the math test sheet with all of you. This is the sheet, right?
जी मैडम.
Now, there are four variables listed here: grade 1, grade 2, before and after. So I will consider first two, grade 1 and grade 2. Next two you can consider for your practice, before and after type of thing. Suppose these are the heights given in the centimeter form. These are the heights given to you, and you want to check whether there is any difference in the height after taking certain types of measurement of increasing the height or something like that, right? I think I will not say height, because height cannot reduce. It can be that or it can be increased. So it can be any variable which you can say, maybe it is cholesterol, BP or something like that. You can take such kind of variable these, right? Coming to the grade 1 and grade 2, right? Now you can find we are having two variables, grade 1 and grade 2. Suppose I'm having the scores of my students before teaching them any particular concept, and then I have taken their scores after teaching that particular concept, right? So that way I collected the grade of the students twice. So you need to have these grades in a same number. Means go down. Yeah. You can find 359, 359, right? In both the conducts, you need to use same sample. So suppose for the first conduct, for the first test, suppose I have taken total students as 359. In the second conduct also, I need to use same 359 students. Clear to everyone? Now, second thing is, if I talk about the assumption says you need to have the dependent variable which you need to measure twice. The dependent variable is suppose grade, which I have measured twice, right? Now, according to the next two assumptions, you need to have the difference of these grades. So now how to calculate that? Either you can use the Excel, and using Excel you can take the difference. That is the one thing. Or here in that SPSS, what you can do? You can go to the transform menu, and then you can select compute variable. I hope it is okay.
Okay madam.
Yeah. So click on this. Now, suppose I'm giving the name. I think you can see in the target variable, a cursor is blinking. You can give the name according to your choice. I am writing here the difference, right? Up to you, whatever name you want to give. So write the name as whatever is your wish. I have written difference. Coming down.
Sorry, can you repeat? How did you get this tab, compute variable?
Ma'am, from transform tab. Go to the transform tab. And
Okay,
the first option you will get compute variable.
Got it. Thank you.
Yeah. So after this, you need to define your target variable. Target variable means this will be the new variable generated by the SPSS for you, right? So we have given the name as difference. You can give the name according to your choice. Now I want to take the difference of these grades. So I'll come to this particular box. I'll select the first variable, which is grade 1, and shift it to the numeric expression box using the arrow like this. Now using these calculator buttons, you can select the symbol. I am selecting it as minus, selecting the second variable grade 2 and shifting it to the grade 2 box. Is it fine?
Yes ma'am.
Now you can click on the OK button. Once you will click on OK, you will get the message that compute difference is performed. Come down to the main data file. In that you can see now the next at the end the new column is added with the name difference. I hope everyone has found it. I hope everyone is getting it.
Yes ma'am.
Yes, ma'am.
Fine. If you got it, further what you need to do? You need to go to the analyze descriptive statistics and explore. I hope. May I click on this?
Yes ma'am.
Now difference is available. Shift it to the dependent list box. Click on the plots. Deselect stem and leaf. select histogram, select normality plots test, and then you need to press on continue. So may I click on continue?
Yes, ma'am.
Click on this continue button.
Ma'am, please repeat one time again.
From
Ma'am, please repeat one time again from analyze.
no, I'm asking for this explore option.
Yes, ma'am. Yes, ma'am.
Go to the analyze, descriptive statistics, and explore. Then
Yes, ma'am.
shift the difference in the dependent list box. Click on the plots button. Please select stem and leaf. Select histogram. Select normality plots with tests. Done.
Yes, ma'am.
Click on continue. Click on OK. Output is generated for me. I hope everyone has got it.
Yes, ma'am. Got it.
Now you can see first table case processing summary, which is saying how many of the observations you are having. We are having total 359 respondents data, no missing value. Total is 359. Coming down, talking about the descriptive statistics, mean grade is minus 1.17. Then median is minus 1.19, which is very close, right? 95% confidence interval for mean. This is the range. 5% trim mean out of when we are removing the outliers. This is your trim mean. Variance, standard deviation, minimum grade, maximum grade, and the range. Coming down, the interquartile range and skewness and kurtosis. So looking at the skewness and kurtosis, you can find these two are in the range. Very, skewness is almost zero. You can say this very close to zero, right? Skewness should be zero if for the normality parameters. If you can recall, I already discussed this. But kurtosis should be 3, but I think it is very close to 0. Coming down, looking at the normality, you can find here Saproville's significant value is coming as 0.108, which is greater than or less than
Greater than.
Greater than.
it's greater than 0.05. That means we are going to accept the null hypothesis of Saproville, which says that difference is normally distributed, right? The variable, whatever you are taking, which is normally distributed. So this is the assumption which we have checked. Histogram, I think you can see, you can double click, you can put this distribution curve on the histogram, you can close it, you can close your chart editor, you can see this is the histogram, right? Now coming down, looking at your QQ plot, you can find almost many of the data points are following the fitted line. There are certain deviations for the few of the points, but you need to decide upon which of the method you are using to ascertain the normality, right? Going down, looking at the box plot, you can see there are certain circles available beyond the upper whisker of the box plot. But if you can recall, I told you this thing that when asterisks are coming in SPSS, generally those asterisks are indication of the significant outliers. Significant outliers will badly impact your results. But insignificant outliers, which are represented by circle, they will not that much impact your results. But still, that will totally be the call of the particular person or the analyst whether he or she wants to keep those data points in the data or not. So that you need to decide. But I think I am okay with this, as this is the demo of the paired sample t-test. So I think I'll go with the paired sample t-test. We have seen all the assumptions are met here. Now to perform paired sample t-test, you need to go to the analyze, click on the compare means and select paired sample t-test.
Excuse me, ma'am.
Found it?
Yes, ma'am. Excuse me,
Click
ma'am.
on the click on the paired samples t-test. Box is coming of the paired samples t-test. Now I'll shift my first grade in the variable 1, second grade in the variable 2.
Excuse me, ma'am.
Yes.
मैम इंटरप्शन हो रही है, आवाज बीच में कोई दूसरा जो है वो उसका वॉइस चल रही है, तो थोड़ा सा एक बार उनको म्यूट कर दीजिए.
Okay, I think we need to check who is he or she. Can we check?
रीमा और समथिंग एल्स.
Okay. Reema ma'am. I think
Yes,
ma'am.
ma'am. I'm mute.
No problem. Done. Thank you. Okay, so I think I was on where I was here. I think we haven't performed paired samples, no?
Analyze pair sample.
Yeah. I think I have switched my screen, so it has disappeared. So again, I'm going to the analyze, compare means, and selecting paired sample status. Click on this. Shift your one variable in the variable 1 box, second in the variable 2 box, and then nothing you need to do. But if you want to see the confidence interval percentage, you can click on the options. You can find it is 95% set by the SPSS. If you want to make changes, you are free to do that. You can click on the continue button. Clicking on the continue, then after we will be returning on the box, you need to click on the OK button. This will generate your results. I hope you got it.
Yes, ma'am, got it.
Yes, ma'am.
Okay, so we are starting with the interpretation part. We can see the first table is for the paired samples statistics, which says grade 1, grade 2 average are giving here. So grade 1 average is 6.01, grade 2 average is 7.19. These are the mean averages for the grades. These are the number of observations for both the pairs, then standard deviation of the grades for both the different grades, and standard error of mean. Next table is for the paired samples correlation. So whenever you're applying the paired sample status, you always get the value of correlation. If you have performed paired sample status using the Excel, in that also you are getting the correlation value. The concept is very simple, as we are having the pairs, so that is why it is generated the correlation. It is looking at the relationship between the pairs, which is coming as 0.007, which is very low, right? So usually it should not be that much low, but here it is coming in this data, it is coming very low. Going to the next or the last table of the output, which is for the paired sample status, you can find here the mean difference is coming as minus 1.17. Standard deviation is coming as 5.516. Standard error of mean is coming as 0.027. Further, main thing is the t-test value, which is minus 43.150 for the 358 degrees of freedom, and the significant value for the t-test is 0.000. So can anyone interpret here what we will conclude? Anyone?
Ma'am, here we reject the null hypothesis because significance level is less than 0.05.
Yes, significant value is less than 0.05. That means we are going to reject the null hypothesis of the paired sample status. And can anyone tell me? I think we haven't formulated that hypothesis. What will be the hypothesis?
Ma'am, there is no significance difference between group 1, mean of group 1 and group 2.
Yes, there's no significant difference in the mean of group 1 and group 2. Very correct. This will be the hypothesis. So what we can do here, we can interpret, we can say this thing that there is, because we are rejecting the null hypothesis, so we are saying there is a significant difference in the mean grade before teaching and after teaching, right?
Yes, ma'am.
Right. Now, if I want to see whether there is an improvement in grade or not, so how I can do that?
By looking at mean.
By looking at mean, very correct. You can compare the mean values. You can say here as the comparison, because why we are making the comparison, because the result says that the difference is significant, right? So we can say that mean is 6.1018 for the grade 1, and for grade 2 it is 7.19, right? So that way you can say this thing, there is a difference and this difference is significant. Or I can say second grade has improved, right? So that means teaching was effective, right? The scores or mini scores has improved. Clear to everyone?
Yes, ma'am.
Right. And then you can see also the mean difference. This mean difference is minus 1.17. So why it is negative? Because we have taken grade 1 as a first group and grade 2 as a second group. So small figure, we are subtracting the higher figure. Means small figure minus higher figure, it will give you obviously the negative figure. So that means grade 1 mean is less than to the grade 2 mean. Or I can say this thing, that the teaching is effective. So that is why there is an improvement in the grades of the student. Is it okay?
Yes, ma'am.
Yes.
Okay.
Okay. So I think this is about the two different independent and dependent paired sample status, is also known as the dependent sample status. So I think this is about this. I will conclude my session on this point, that you need always to have a clarity about the type of variables and number of variables you are having. You need to see what is your purpose, whether you want to see the difference or whatever you want to see. Accordingly, you can ascertain the test. Talking about the case of independent and dependent sample status, firstly, we have seen the independent sample status, where I talked about that we need to have two variables, one dependent, one independent. Dependent should be numeric or continuous. Independent should be the categorical with the two categories, right? So this was the requirement. Further, we have seen assumptions. Most of the or most important assumptions were of the normality and the equal variances, right? And then we have seen that how we have performed this test using the SPSS, and then we have seen the output and interpreted it. Talking about lastly the paired sample status, there I told you the concept. In case of paired sample status, we need to have same number of people uh, in both the conducts of any particular thing. Generally, for the experimental type of studies, we are using the paired sample status. Then we have seen the assumptions, and then we have seen today, I think we have seen one more thing, that is how we can use the compute option, which is available under the transform. And then we have calculated the paired sample status using the SPSS, interpreted the results, and that way I think I tried to explain you both the t-tests. So till now we have completed all the t-tests. One sample, in two samples we have completed in independent samples and the dependent samples, right? So I think this is from my side for the day. Now the platform is open for the question and answers if you are having any. Any questions, friend? I hope I'm audible.
Yes, ma'am.
Yes.
Audible.
Okay, fine. So any questions?
No, ma'am.
Okay. No questions from anyone's side?
Ma'am, one thing there is how to see curve on histogram, ma'am. Please explain one time.
Okay, give me a second. I'll share my screen. Give me a second. So I'm sharing my screen. Screen is visible?
Yes, ma'am.
Yes, ma'am.
Now what you need to do, suppose I'll come to this. This is the histogram, right?
Yes, ma'am.
You need to double click on the histogram. Chart editor will open. right?
Yes, ma'am.
Here you can see in the toolbar, which is below the main toolbar, you can find various graphs are there. You can see the second option, second last option, which is the hide distribution. Suppose I'm hiding this, right? Okay, just a minute. So I'll click on this show distribution curve. The properties box will open. There you can find the normal distribution is by default option selected by the SPSS. So we'll go with this. You can only close it. You can see this is the bell-shaped curve kept on the graph histogram on the chart editor. You can close this. You can see this is there.
Okay, thank you, ma'am.
Thank you. So any other query?
Ma'am, in order to know the impact of something on some other thing, t-test is required, and in order to know the significant difference, what else can be performed?
Ma'am, a significant difference we can see using various tests. Z test is used, T test is used, ANOVA is used. So you can use
Yes.
various tests to see the significant difference. But for finding the impact, I think in upcoming days I'll talk about. I think tomorrow itself I am going to talk about the regressions, right? So there we are
Right,
talking
ma'am.
about the finding of the impact, right?
Right, ma'am. Right. Right.
Fine. Okay. Any other questions?
Ma'am, actually, where we apply t-test, where we apply chi-square test, where we apply ANOVA, this is the major problem for different testing.
Yes, I think from first day only, I think discussing this thing, I have explained you when you are interested in finding the uniform distribution of the frequency, you will go for the chi-square goodness of it. When you are interested to find the significant association between the two categorical variable, you will go for the chi-square independence of attributes. If you want to see the difference, you will go for the t-test. And I think from yesterday and tomorrow, today itself, I have talked about that what is the variable requirement of the various kind of teachers. So if you people are making your notes, I don't think so there will be this type of problem for you. Only you need to have the practice type of things, that which variable is on which particular scale. And I think till now you will having the idea for independent sample status, two variables are required, one dependent, one independent, or continuous, or the categorical scale variable, something like that. So if you are having your notes and if you are practicing it, I don't think so you will face any problem,
Okay, madam.
right? So I think this is what my humble request from all of you when when I am discussing the conceptual aspects of any of the tests. So I request you, please try to make down your notes, because I don't think so that PPT will help you out, because that PPTs are in my words, and it is according to my understanding. But when I'm explaining whatever you are understanding, try to write those things in your own words. So I think this is what will help you in future, because if it will be in your own words, you would be easily understand, or you can refer those particular thing in the future also. But if you will get a PPT, you are not making any of the notes, I don't think so that PPT will help you out. So this is my humble request and suggestion. Please try to note down your points.
Ma'am, one more question. Ma'am, the most of the tests that we've discussed and the variables that have been assumed are measured on a nominal or an ordinal scale, right? So, do these same tests work for variables measured on interval and ratio scales as well, or there are different tests for those particular variables?
No, Ritika ma'am, when I'm telling you continuous variable, meaning is it is an interval
Right.
variable for the ratio variable.
Got it. Okay, right. Continuous variable. Yes, ma'am.
Yeah,
Okay.
continuous variable means it is either an interval scale variable or it's a ratio scale
Ratio
variable.
scale variable. Got
Yes.
it. Okay, ma'am.
And
Thank
I think when you have coined this thing, I think I want to tell you, all of you, it is not like I'm interacting with Ritika ma'am only. Always we need to see the nature of the variable. Means suppose I'm talking about weight, right? Weight of the students, right? It is quite obvious. Suppose I'm having the weight as 56, 52, 43, 40. But we know this thing that weight can be expressed in terms of decimal points also. So you will define that weight is not a discrete variable, weight is the continuous variable. So you need to see this thing. Similarly, I think when I talk about the research studies, because here I'm taking very basic examples, right? But if suppose you are using any questionnaire to collect the data, suppose because I think I am not talking about the factor analysis in this particular FDP, but if suppose you are measuring any particular construct, say for example motivation level in person, and you are using 10 questions or 15 questions, suppose, for measuring the motivation level. So what you can do, you can take the average of the questions of a particular respondent answers, and that way it will become the continuous scale variable. Fine, ma'am?
Okay, we got it, ma'am. Thank
Yeah.
you.
Thank you. Anything else?
Excuse me, ma'am.
Yes, sir.
Ma'am, I want to take a proper knowledge of full SPSS. Then how I can get it?
Sir, may I know how much you are knowing about SPSS?
मैम SPSS में जैसे uh, in this session we have discussed only descriptive statistics and yeah, extract and analysis and so on. Some more tools are there in SPSS, so I want to take knowledge of those tools also in detail.
Means you are having the basic understanding of SPSS, right? This is what you are saying?
Yes, ma'am.
Okay. So, sir, I think all the statistical tests, if I talk about in case of SPSS, are listed under the analyze. So you can explore by your own. Everything is there. You can take the help of YouTube. You can take the help of Google. So that particular software will guide you. But I think only difference is that there you can only get whatever is written there. That only you will have the knowledge. If you are having any question that you cannot means what I can say solve or resolve using by any particular person or somewhere, right? So that can be the only problem. But I think if you want to get the basic understanding that how to apply this test, any of the YouTube channel, or maybe if you will do the Google of on any particular topic that how to do this using SPSS, that will help you out to understand that. So that
Okay,
type of understanding you can get, or else means I think I will not say I'm an expert of a field or something, but I think I'm having a little bit knowledge about SPSS. So usually we are only means I think since last 4 5 years I'm discussing only these topics, but uh, probably in 1 month or two I'm planning on coming with some different statistical tests. Like I'll go for the multivariate analysis also. But problem is I'm not getting that much time. As soon as I'll get time, probably you will be having those type of sessions also. Maybe there I'll be the instructor, I'll be the mentoring person there. So I'll try to guide you people there. So give me some time. I'm developing those things, because thing is that you need to collect so many things once you are teaching those things. So
okay,
once
ma'am.
I'll be ready with my material, definitely we will organize some more programs on the SPSS, multivariate
Okay,
analysis type of things.
okay.
So I'm planning to include factor analysis, two-way ANOVA, MANOVA, using SPSS, multiple regression using SPSS. So soon, I think I'm having so many things available with me, but problem is that I need to have clear, because once you are delivering any session, so it is not like and one fine day I'll get up and I'll deliver the thing. I need to have everything ready with me once if I want to deliver something. So those preparations I need to make.
Okay, ma'am.
Ma'am, please
Just a
take
minute,
some
just a
paper.
minute, just a minute. Session with him. Next session with you. Okay. Yes.
Ma'am,
Sorry.
it's a humble request to please take some session like this on MOS software also.
Problem with MOS is that, ma'am, okay, I'll try. I do not have any problem. But firstly, I'm planning for the EFA, because MOS is for the CFA and SEM.
Okay,
Right.
ma'am.
Ultimately, so firstly, I'm planning for EFA because that will be the base. And after that, I think we can go for the CFA and SEM.
Okay, ma'am.
Yes.
Ma'am, along with CFA, can you please begin with regression and reliability? How to test, verify the reliability?
I think reliability we already included in this
Yes,
7 days
yes,
of the field.
yes, yes. You
Yeah,
have
validity
included,
we
but
have not did, because validity we need to we can get using the MOS, that for CFA. So that we will cover once I will design everything properly, so that we will do in the MOS sessions. Okay, any other questions? Fine. So, I think this is all from my side for the day. I request you if you can switch on your cameras and I can capture you for the day. Great. For us, sir, I think first time I am looking that how you are. Thank you, Sonali ma'am, Amita ma'am, Vivek sir. That's great to see you all. It shows that you people are listening to me, and because that is why you are here till the last call. So give me a second. I think I have taken your pic, but I need to paste it whether it is coming correctly or not. Just terminate. Please do not switch off. Done. Thank you. Thank you, everyone.
Thank you, ma'am.
Good night. We will meet tomorrow for the
Thank you, ma'am.
Yes, we will meet tomorrow
Thank
for
you.
the next session, which will be on correlation and regression. And then Sunday will be off, and we are meeting on for the last session on the Monday. Right?